This is a really good geometry puzzle. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So what is the shaded area? We have two circles with the radius of 1. So two circles with a radius of 1. And these two circles, they intersect such that the boundary of one circle touches the center of the another one. For example, the boundary of this circle touches the center of the other one. In other words, we can say that the distance between these two centers is just one radius. So this whole distance is one radius. What is the area of this shaded region or this area of this intersection point? So we have two circles. Now let's draw some lines to make it easier for us to comprehend. So let's draw some radius, right? So let's focus on the right circle. Let's draw one radius to this intersection point. So that's 1 unit, right? Let's draw another radius between the two centers, right? This is also another radius. So we are still focusing on the right circle. Let's draw another radius here. Let's focus now on the left circle. Let's draw one radius and also another radius. So we ended up with two equilateral triangles with the side of 1, right? Because these are all the radii of these two circles. So we have two equilateral triangles. The shaded area, let's focus on the shaded area now. The shaded area is comprised of these two equilateral triangles, right? Plus these little segments, right? So we have 4 of these little segments, like this segment, this one, and this one. So we can say the area, the shaded area equals 2 of these equilateral triangles plus 4 of these little segments. So we know that the angle in an equilateral triangle is 60 degrees, right? So let's just calculate the area of one of these triangles. So area of this triangle equals, so you can use any formula that you like. You could use, for example, Heron's formula, or you can say, so we have two sides of this triangle and the angle in between. So we can say the area of this triangle using this formula equals 1/2 AB sine theta, and theta is the angle between these two sides. So let's just calculate it. Area of this triangle equals 1/2 AB, so A and B are just 1, and sine theta, sine 60 degrees is √3/2, right? So the whole area is √3/4. Let's just multiply that by 2 so we find the area of these two triangles. So multiply √3/4 by 2, it becomes √3/2. So that's the area of these two triangles. So we found the area of these two triangles. Let's now focus on these little slices or segments of the circle. We're finding the area of the segments of a circle. At first, you need to find the area of the sector. So let's say we have a sector here of 60 degrees, right? This is 60 degrees. We have a sector, an arc, let's say a sector of 60 degrees, which is 1/6 of the whole area of the circle. And then you can subtract the area of this equilateral triangle from that sector. And then finally, you can calculate the area of this segment. So let's say area of the sector, 60-degree sector, equals pi r squared over 6. So since the radius is just 1, since the whole area of the whole circle is just pi, so we can say it is just pi over 6. So that's the whole sector. Now we need to subtract this, subtract the area of one triangle from this one. So the area of segment, the little segment, equals pi over 6, which is the area of the sector, minus the area of the triangle, so which is root 3 over 4. So that's the area of one of these segments. Now we need to multiply that by 4, right? So we need to multiply that by 4, so because we have 4 of these little segments. So 4 segments area, let's say segments, equals 4 pi over 6 minus 4 root 3 over 4. So let's just simplify that, which is, you can just simplify this. So 2 pi over 3 minus root 3. And then we have the 4 segments now. And then we have the area of the 2 triangles. And then we can just add them up to find the area of the shaded region. So area of shaded region, let's say, equals area of 2 triangles, root 3 over 2, plus area of the 4 segments. So 2 pi over 3 minus root 3. So let's just, the rest is just calculation. Let's find a common denominator here. So the common denominator here is 6. So 3 root 3 plus 4 pi, then minus 6 root 3. Let's just simplify the top part of this fraction, the numerator here now. So let me just write it down here. It becomes, let me start with 4 pi minus 3 root 3 over 6. And that's the final answer. So we can simplify that further. Maybe we can just write it like this, so that it becomes easier to understand. 1/6 over 4 pi minus 3 root 3. And that's the final answer. That's the area of the shaded region. So that was the, I think, easiest method, but make sure to drop your thoughts and answers and your method as well and put it in comments below. But I have 2 more challenges for you. So first challenge, which is the easier challenge, is what is the area of this whole shape, right? The area of this whole shape. So obviously that's easy. It's a little tricky, but it's very easy. Second challenge, though, it's a little more complicated. You need to focus on your spatial understanding and reasoning. So here we were on the 2D plane, on the 2-dimensional plane. So what if we were on a 3D-dimensional, 3D or 3-dimensional plane or space, which is instead of circles, what if we had spheres? So the same setup, instead we had spheres. So imagine 2 spheres with a radius of 1. They intersect such that the centers of these 2 spheres, the distance between the 2 centers is just 1 radius, or the boundary of 1 sphere touches the center of the another sphere. So what is the not area, but what is the volume of this intersection point? So make sure to calculate it and drop your answers and methods in the comments below. And please, to support the channel, like the videos and subscribe to the channel. See you on our next video on prime logic.